In this tutorial, we are going to talk about logarithm and exponential. We are going to know how to sketch log and exponential functions, how to evaluate, how to solve the equations, and also how to solve the simultaneous equations of log and exponential. And we'll go further and to also talk about differentiation of log and exponential functions. So let's begin our discussion with question 1 and 2. So the first question is saying, sketch the graph of the following function and state its domain and range. Okay, so whenever you are trying to graph exponential, now this is the exponential. How do you know that this is an exponential? An exponential is in a form of a to the power x. Okay, then when we're talking about log is in a form of, it's either they use log or ln, okay, which is natural log. So now in this case I know that this is exponential because it is raised to the power. I've got a raised to the power x. Okay, so to sketch this, I'm going to start with the first one. So now sketching exponential is something that is very important and very simple at the same time. Now exponential function have got what we call horizontal asymptote. All exponential function have got what we call horizontal asymptote. Horizontal asymptote is the number which doesn't have the power. In this case, f of x is equal to 3 raised to the power x plus 4. There is no number which doesn't have x or which doesn't have the power. So the number after exponential or before exponential, that is the horizontal asymptote. In this case there is plus 0. So the horizontal asymptote is 0. 1. 2. Equate the power equal to two things. Equate the power equal to 0 and also equal to 1. Then solve for x. Why am I equating to 0 and 1? Because I know that any number to the power 0 is 1, any number to the power 1 is the number itself. Then just have your two coordinate. You have x, y, so you have got it. So first solve for x. The first one is x plus 4 is equal to 0, meaning x is equal to negative 4. So put negative 4 here. The next one is going to be x plus 4 is equal to 1. Then x is equal to 1 minus 4. X is equal to negative 3. Put negative 3. After finding this, now go back to your function. If I'm to plug in the values now, y is equal to 3. Where there is x, let's put negative 4. Negative 4 plus 4 is 0. So it's y is equal to 3 raised to the power 0. Any number to the power 0 is 1, meaning here there is 1. If I put negative 3 there, it's going to be negative 3 plus 4, which is 1. So it's going to be 3 raised to the power 1. Any number to the power 1 is the number itself, so it's going to be 3. What I mean, guys, is this. I have negative 3 plus 4, so I end up having 3 raised to the power 1. So the answer is 3. That's why I've put 3 there. After finding this, then come up with your simple sketching. Now you have your horizontal asymptote at 0. Now this is y is equal to 0. Horizontal asymptote is cutting the y-axis, so it's going to cut there at y is equal to 0. There, that's the horizontal asymptote. In x I've got negative 4 and negative 3. So in y I've got 1 and 3. 1 and 3. Let's see. Negative 4 comma 1 is here. Then negative 3 comma 3 is there. What does it mean? This graph, starting from here, not really touching asymptote, just near the asymptote, touching those 2 points. Okay, so I can put that point to be here. So that's the graph. Now how do you find the domain and the range of the function? Okay, to find the domain and range, what you are going to do here is this. The domain, these are values of x. So for all exponential function, the domain is from negative infinity to positive infinity, because we can clearly see that we don't know where it's starting from and we don't know where it's ending. So for any type of exponential function, the domain is from negative infinity to positive infinity, but the range is restricted. Then that is true again. The opposite is true for logarithm. Logarithm, the range is from negative infinity to positive infinity, but the domain is restricted. It's just the opposite. So please take note of that. Okay, so what is happening now is this. The range is starting from the horizontal asymptote, but that horizontal asymptote is not included. So you say the range, the horizontal asymptote is 0. So you say open because it's not included. From 0 all the way to positive infinity, because we don't, it's starting just near 0, not including 0, but just near 0, all the way to positive infinity. That is it for exponential. That's the basic idea behind exponential, graphing exponential. Now here what I'm going to do now is I'm going to, I think you can go ahead and solve this. You are going to equate that one just negative x to two things, meaning the horizontal asymptote at that point is negative 1. So you equate negative x, you're going to say negative x is equal to 0, negative x is equal to 1. Then you start now plugging the values. Then you come up with a sketch. I want you to sketch for 2 and send me the answer. So I'm going to sketch for 3 because it has got 3 outside, so you might be disturbed with it. You might be confused with 3 outside. Okay. So the horizontal asymptote, like I said, the number which doesn't have the power. So this, I can't say that the horizontal asymptote is this, but the number after the exponential, this is the exponential. The number after the exponential is negative 3. That's my horizontal asymptote. Equate the power equal to two things. So negative x will be equal to 0 and negative x will be equal to 1. So for x, here x will be equal to 0 because if I divide both sides by 1, still is going to be 0. Another one, x will be equal to negative 1. Have this. Put negative 1 and 0. Now you have got your function. Let's say y is equal to 3, then 3 raised to the power x minus 3. So where there is x, put negative 1. So it's negative, then negative 1, then minus 3. So y will be equal to 3. This is going to be negative, negative is going to be positive. 3 to the power 1 is 3, minus 3. So 3 times 3 is 9, 9 minus 3 is 6, meaning y is 6. What if I put 0? You see what I've done for, the way I've done this one, guys, these ones, is basically the same thing which we're going to do there. Okay. Y is equal to 3, 3 raised to the power negative. So there I'm going to put 0. So 0 times negative is just basically 0. So meaning is I've got it, y is equal to 3. Any number to the power 0 is 1. So y is equal to 3 minus 3, 0. Let's see. So my graph will be here. My horizontal asymptote is at negative 3. I'll put negative 3 here. In y, I have 6. I'll put 6 there and 0. 0 is there. Here I've got 0 and negative 1. That's all. So the first one is negative 0,6, which is here. And the second one is 0,0, which is there. What does it mean? The horizontal asymptote is here. So it has to start from the asymptote, then it has to touch those 2 points. Starting from the asymptote, learning away, touching those 2 points. That's the graph of this guy. Now, what is the domain? Like I said, the domain is from negative infinity to positive infinity, always for exponential. Then for the range is restricted. So the range, you say it will start from negative 3 all the way to positive infinity, not included. Okay. I think from what I've done here, I believe you can do the same for the last part, which is this one. But anyway, let's just solve together the last one. So I want you to go and solve this one. You send me the answers, or you can just type the answer, the graph. No, it's not possible in the comment section. Anyway, you can just, if you have my number, you can send me the answer. Okay. So y is equal to negative 2. Let's first talk about the domain. The horizontal asymptote is positive 8. Equate x equal to two things, 0 and 1. X, y, 0, 1. So y is equal to negative 2. When I put 0, plus 8. Any number to the power 0 is 1. Okay, meaning what I'm going to have is -1, okay, plus 8. So -1 plus 8, I'm going to get -1 plus 8, I'm going to get what? I'm going to get 7. So here I'll put 7. If I put 1, it's going to be -2. -2 plus negative, so I'll have -2 plus 8, which is 6. Come up with a simple sketching. What do we have? There was not asymptote is at 8. I'll do this. 8, I'll put it here. So I'll put 7 here and I'll put 6 here. In x I've got 1 and 0. So 0,7 is here. 1,6 is there. What does it mean? The graph is starting from this point, touching these 2 points. We don't know where it's ending. Domain is always from negative infinity to positive infinity, but the range is now restricted. So the range will start from negative infinity. We don't know where it's ending, from negative infinity all the way to 8. 8 is not included because it is the horizontal asymptote. So that's the range. That is it for question 1. Let's see how we can solve question 2. It's the same thing. The horizontal asymptote e raised to the power x, that is an exponential. Horizontal asymptote for the first one, there is no number which doesn't have exponential, which so is going to be 0. Equate those two guys equal to two things. Equate them equal to 0 and also equate them equal to 1. So for x, the first one is going to be 2x is equal to 1, then divided by 2x will be equal to half. The second one is going to be 2x is equal to 1 goes there, is going to be plus, so it's going to be 2, then x is equal to 1. Have your coordinate. So the first one you have got 1 over 2, then you have got 1. Now I want to remind you that the value for e is approximately 2.71. Okay, so now what you are going to be doing is that when you put e where there is 1, for example here is going to be e y is equal to e raised to the power 2, where there is x, let's put half, minus 1. So it's going to be 1 minus 1, because half of 2 is 1, 1 minus 1 is 0. So you have e raised to the power 0. Any number to the power 0 is 1. Then now if I put 2, it's going to be, or if I put 1, sorry, it's going to be e raised to the power 2, then minus 1. 2 minus 1 is e to the power 1. Any number to the power 1 is the number itself. So now, one thing we have to keep in mind is that that's the approximate value of e. So after having your sketch, what's going to come now is this. So I have got my x to be half and 1, so I'll put half here, then I'll put 1 here. In y I have got now e is approximate 2.7, which is greater than 1, so I'll put e here. Don't put 2.7, just put e, but you know that it's going to is approximate is 2.7, so then I'll have 1 here. My horizontal asymptote is at 0, so I'll put 0 there. Then let's now see, half comma 1 is here, 1 comma e is there. What does it mean? Starting from this point, running away from the asymptote, touching these 2 points. So I'm supposed to put at least, just, it's a sketch, so you can put it there. So it goes there. Yeah, so that's the graph of this guy. So what's the domain? The domain is from negative infinity to positive infinity, but the range is restricted. The range will always start from the asymptote, in this case, starting from the asymptote not included all the way to positive infinity. As simple as that. I'm going to solve I think this one you can solve. Let me solve this one. Okay, so I have got negative 2, the horizontal asymptote is still 0, so x will be equal to 0 and x will be equal to 1. 0, 1. So let's see, y is equal to negative 2, where there is x we put 0. Any number to the power 0 is 1, so y is equal to negative 2. So I'll put 2, negative 2 there. What if I put 1? It's going to be e. So it's like now you have got y is equal to negative 2e, of which negative 2e, I'll just put here, it's fine, I'll put negative 2e. Negative 2e is the same as negative 2 times 2.7, which is approximately 4 point something, or let's say 5 point something. So that's not going to affect anything for our graph. I'll have this. My horizontal asymptote is 0. I cut there. Then in x I've got 0 and 1. I'll put 1 there. 0 is already there. Then I've got negative 2. Now negative 2 times that one we said is approximate, so I'll just put negative 2 times e, just like that. Then now see 0 comma negative 2. This is negative 2 is here. Then 1 comma that one is there. What does it mean? The graph is starting from this point, touching these 2 points, just near the asymptote, not necessarily the asymptote, but just near the asymptote, touching those 2 points, going like that. That's the graph of that guy. As simple as that. Let's do the last one. So I want you to solve this one like I've said. You also send me the answer. Let's do this one. So this one, we know that I'll equate x equal to two things. X squared is equal to 0 and x squared is equal to 1. So therefore x will be equal to 0. The square root of 0 is 0. Then here x will be equal to 1. The square root of 1 is 1. What is the horizontal asymptote? The horizontal asymptote now is e, negative e. Okay? So I'll have my coordinate xy. So I've got 0 and 1. So I've got y is equal to e raised to the power x squared minus e. Y is equal to, where there is 0, when I put 0 squared is 0. Any number to the power 0 is 1. So it will be 1 minus e. 1 minus e, just put 1 minus e, just like that is fine. Then the next one is going to be, but of which you know that e, I said, is approximate 2.71, approximately, but it's, maybe it can be more than that anyway. So y is equal to, let's put now 1, e raised to the power x to the power squared minus e. So where there is x we put 1. 1 squared is 1. Any number to the power 1, so it's going to be e minus e, which is 0, like that. So you do this. The horizontal asymptote is negative e. Negative e is approximately negative. It's approximately negative 2.7, like we have said. E is 2.7, so since it's negative, it's going to be approximately. So I'll put it here, negative e, like that. Next, I'm going to have 0 comma 1 minus. So 1 minus e is now, it's more like we're saying 1 minus 2.7, which is negative 1 point something, which is going to be here. Just put it here, 1 minus e. So I have got 0 comma 1 point, that is this point. Then 1 comma 0, 1 is here, in x 1, in y 0 is there. So starting from this point, touching those 2 points, let me sketch it. It goes like that. That's the graph of this guy. So I've only left one which we are going to solve, so you send the answer for that one and that one. That is it for question 1 and 2. So now let's talk about question 3, which is saying evaluate the following expression. So the best way to evaluate this, guys, is I have got log, which is 1 over 10. Log, when there is no base, it is always in base 10. Okay, meaning that I can write this. I know that 1 over 10 is basically the same as 10 raised to the power negative 1. What I want you to understand is this: if you have got log, okay, if you have got log of a of b to the power n, is basically the same as the n can come in front, then it can be expressed like that. Okay, so now what it means here is I know that I want you to understand that when you're talking about log, okay, log base 1 is 0, then ln 1 is also 0. So like I've said here, just know that I've solved this one and this one. So log, regardless of base, any base, as long as it's log 1, is 0. Ln 1 is also 0. So I've solved those two. The answers are 0 there. Then if I go to this one, I know that it's going to be log of 10 raised to the power negative 1. So the property of log allows me to shift the power to be in front. So it will be negative 1 log 10. So it is log 10 base 10. So if you have got log of a, it is basically 1. So log of base itself is 1. So the correct answer is going to be 1 times 1, which is just negative 1. Okay. Now we go to part 2. Part 2 is saying we have log. The square root, we know, guys, that the square root is the same as 10 raised to the power half. The property of log allows me to shift the power to be in front. So half log 10. So log base 10 of 10 is just 1. So 1 times half is half. So that's the answer there. Okay. Then if I have got log or ln e, ln is always in base e, but they will not show it. Okay, it's always in base e, but they will not show it. So one thing you should know is that I said log base, if I've got base a of a, log of base itself is basically 1. So ln e base e is just 1. So here the answer is 1. Let's go to the last one, which is ln 1 over e raised to the power 3. So now here one thing should come in your mind is that it's basically the same thing I was talking about. So I'm going to rewrite this to be e then raised to the power negative 3, me removing 1 on top. The property of log allows me to shift the power to be in front, so it will be negative 3 ln e. Ln is always in base e. Ln e of e is 1. So you have negative 3 times 1, which is negative 3. As simple as that. That is it for question 3. So now let's talk about expressing exponential to logarithm, as well as expressing logarithm to exponential. That is question 4 and question 5. So I'll start with question 4. So question 4 is saying express each of the following as exponential equation. So let me first give you the basic idea behind converting from exponential to, or converting from log to exponential. If you have got log base a of b is equal to x, so what we normally do here is you get the base raised to the power what is outside is equal to what is inside. What I mean is a raised to the power x is equal to b. So let's go to part 1, which is log base 2 of 16 is equal to 14. So expressing this to exponential, you get the base, which is 2 raised to the power 14, or which is 4, not 14. This is 4. So it will be 2 raised to the power 4 is equal to 16. As simple as that. So if you have got log, the second one, this is when there is no base, meaning it's in base 10. Okay, of 100 is equal to 2. So it is 10 raised to the power 2 is equal to 100, which is indeed true. 10 to the power 2 is 100. Okay, then when we're talking about ln, which is natural log, part 3, ln is always in base e. So they will not show you that it's in base e, but what you should know is that there is base e here, then there's 1 over e raised to is equal to negative 1. Okay, so expressing this into exponential, you say e raised to the power negative 1 is equal to 1 over e, like that, of which you know that any number raised to the power, but let's just leave it like that. This is the same when I say e raised to the power negative 1, I mean 1 over e. Okay, we go to the last one, which is saying ln x plus 2 is equal to 3. So it's always in base e, so it's e raised to the power 3 is equal to x plus 2. As simple as that. That is now exponential. Okay, then now that is it for question 4. Now, like I said, log a b is equal to x. We said x, a to the power x is equal to b, like that. So for question 5, I'll be following this. Okay, so now what you have to be the power is what is going to be equal to the base. Here is going to be what is going to be, or what I mean is any number which is anything which is raised to the power, that is your base. Then the power is the one which is going to be equal to, for example, the first one is going to be log, meaning 3 is going to be the base, which is outside here is going to be here is equal to 4. So if I want to convert this to exponential, it's going to be 3 raised to the power 4 is equal to 81, which is that one. Okay, so even this one is going to be log. If you want, you can put it in exponential, for example, the way this one is. Okay, it will be easy for me to put it in log. Sorry, if I put it in log, because when we're dealing with log, it's either you use log or natural log. So where there is e, I'm going to be using natural log, because here you can clearly see that they are using natural log. So I'm going to say ln, this is the base. So the base we don't necessarily show this base e, so we don't show because it's just ln. Then this is what is going to be, so I'll have y then is equal to what is equal to 4. So it is e raised to the power 4 is equal to that. Okay, so what of this? So that one is going to be ln e. Ln is always in base e, so you don't have to put e. So you say raised to the power is going to be the power which is x is going to be outside, then 5 will be here, so it is ln 5 is equal to x. Okay, now I want you to go ahead and, so this one is going to be log, the second one, the base is 10, so you don't have to show base 10. Okay, y is equal to x plus 1, like that. That's the answer. Log is always in base 10, so you don't have to show that log base 10. No, it's just log y is equal to x plus 1. Okay, then the last one is going to be log, which is base the base is 4, then outside there will be half is equal to negative half, like that. So that is it for question 4 and question 5. Now let us go ahead and solve question 6 where we are trying just to find the value. Okay, so this is basically the same principle which I was talking about earlier on, where I said if you have log maybe base 2 of 4, what it means here is you need just to try to apply the properties of log, make the base and this guy to be the same, then it's going to give you 1. So you know that log base 2, it can be written as 2 to the power 2. The property of log allows you to shift the power to be in front, so it's going to be 2 then log 2 of 2. So log of base itself is 1, this one, okay, is 1, so it's going to be 2. It's the same principle which we are going to be applying here. So here now I'm going to say the first one is log base 2 of 64. Okay, So now 64 can be written as, if I say 2 to the power 5, 2 times 2, if I do 2 times 2, so 64, it should be 2 to the power 6, not 5. So it's going to be log base 2 of 2 to the power 6. The property of log allows you to shift the power to be in front. So it's 6 log 2 of 2. Log 2 of 2 is 1, so the answer is 6. In a case where you are failing to apply this principle, another method which you can use is, for example, here we have got log base 2 of 64. Just equate equal to x. Then you are trying to solve the value of x. Convert this to exponential, where you are going to say x raised to the power 2. Not x raised to the power 2. You say 2 raised to the power x is equal to 64. So make the base to be the same. 2x is equal to, then it's going to be 2 raised to the power 6. The base will cancel. X is equal to 6. So the answer there is 6, if you are failing to apply that principle. So this one is log base 4 of 64, which can be written as now if you do 4 raised to the power 3 is 64. So it's 4 raised to the power 3. Shift the base to be, or the power to be in front. So the log base of itself is 1, so the answer is 1. If you want, you can apply that other one I was talking about, where you equate equal to x, then you solve for x. So you say log base 4 of 64 is equal to x. 4 raised to the power x is equal to 64. 4 raised to the power x, make the base to be the same. It's going to be 4 raised to the power 3. The base will go, x is equal to 3. This is basically the same thing. Let's go to 3, where you have log base 2 of this. Convert this, is going to be the same as, then 8 raised to the power negative 1. Make this one to have the power, so it's going to be 2 raised to the power 3, but there is negative 1. So it's log base 2 of 2 of negative 3. Shift negative 3 to be in front. You have this. This is 1, so the answer is 3, negative 3. Try to use the same principle. Try to solve this one. You can pause the video, try to solve it, and see how I'm going to solve it. 1 over 27. So you can say log 3 of 27 to the power negative 1, like that. If you want, you can push this in advance. You can say negative 1 if you want. You can say negative 1 log 3 of 27. Then again, you come and say negative 1 log 3 of 27 is 3 raised to the power 3 raised to the power 3. Then you shift again 3, so it's going to end up, you're going to end up having this. So this is 1, so the answer is negative 3. What of this one? Ln 1 over e to the power 2 is basically the same as ln e raised to the power negative 2. You can shift negative 2 to be in front. Ln is always in base e, so ln base e of e is 1, so the answer is negative 2. That is it for question 6. I'm going to question 7, or I'm going to question 8, then I'll come back to question 7. So question 7, because there is a relationship between question 6 and 8, that's why I want to solve first 6 and 8 together. So write each of the following expression as the logarithmic of a single quantity. Let me give you the basic idea behind this. If I have got log, the base is the same. Let me put base 2 of a plus log base 2 of b. So writing this as a single log, if the bases are the same, you just multiply these. So you write log base 2 of a times b. What if you have got minus? If there is minus, what you do is you divide. So you write log base 2, then the one having negative is going to be on the denominator, so it will be a divided by b. That's the basic idea behind simplifying log into single quantity. So the bases will always be the same. Okay, the base will always be the same. So this one is going to be log, the base is base 10. You are just multiplying. I'm solving this one, you are just multiplying this, so it's going to be x squared times 1 over x, of which you can try to cancel one x and you end up having just x. So that's the answer for the first one. The second one, the bases are the same, so it's going to be log base 3, 9 times 9. Okay, now here you can't first go direct because you have something in front. Here you have, I have log base 3 of 9 plus 3. So that 3, the property of log allows us, like we said, if we have log base 3 of 2 to the power 3, we would have shifted this to be in front. But in this case, it's opposite. We are shifting what is in front to be the power. So it's going to be log base 3 of 2 raised to the power 3. Then it's going to be log base 3 of 9 plus log base 3 of 2 to the power 3 is 8. Okay, so now to write this as a single is log base 3 9 times 8. Okay, so what is 9 times 8? 9 times 8 is 72. So that's the answer. If we go to the next one, it's the same thing where you are going to shift the 4 to be the power, so it's going to be ln y to the power 4 minus ln 4. The base is e, so this will be expressed as ln base e of y. Now this, there is minus here, so you're going to divide, so there will be y to the power 4 divided by 4. That's the answer. The last one we are trying to write it as a single logarithm, but I feel like they forgot something here. I don't know if maybe it was supposed to be minus ln something, okay, of which, so the way it is going to be, I'll shift 6, that is going to be 6 to the power 2 minus 1. So ln, that is going to be 36 minus 1. So here we were trying to write this as a single quantity. You can't go anywhere here. That's why I'm saying they were supposed to add something here. More like maybe it was supposed to be maybe negatively in something. Yeah. So like the way it is there, we are trying just to express it to simplify it. So we are ending there. Okay, there's nothing that we can do from here. So that is it for question 8. So let's talk about question 10, which is saying use the change of base formula to prove the following statement. So log a, or log a base b is equal to 1 over log b base a. So let's change the base now. We are changing the base of this to base a. So when you want to change the base to base a, you just write this log, write a there, put a leave a space, then log, write b here. Later on, come and put the base to be there. Now what should come in your mind, that log of base itself is 1, so on top there is going to give me 1. So we can see that the left hand side is equal to the right hand side, hence proved. That's how it is there. Question 11, how can we show that log e is equal to 1 over ln 10? Okay, so there we go. I want us first to get log e the way it is. Now I'm going to equate equal to x, so it's more like I'm solving the value of x. Allow me to do that. Log is always in base what? log is in base 10, so it will be 10 raised to the power x is equal to e. Okay, when I do this, what I'm going to do now is the property of log allows me, when there is e here, I'm going to put now ln. Okay, I'm going to put ln. So what I'm going to do is this. You have seen I've just converted, I've just introduced x. X is just something which is going to help me to find the value, guys. Okay, so I'll say I'll introduce ln both sides, so it will be ln. Okay, it will be ln 10 raised to the power x is equal to ln e. Is that okay? So what I'm going to do now is the property of log allows me to shift the power to be in front. Okay, meaning I've got x ln 10 is equal to ln e. Ln e is 1. Now x is just something which I had to put just to help me to find the value. Initially there is no x. Okay, it's more like I'm trying to find the values of x, so I want just to make x as a subject of formula, then that will be my answer now. So I have got x 10 ln e is 1. Divide both sides by ln 10. Here ln 10. So these will cancel. X will be equal to 1 over ln 10. Now I can clearly see that this is exactly as what I have here. If I want, I can come from there to there. So this is how you can show. Okay, so you just say the left hand side is equal to the right hand side, hence shown. Simple.